Welcome back to the MathMinds project, Tuesday live meeting, 6 p.m. every Tuesday, featuring students across CUNY, predominantly from Brooklyn College, go Brooklyn College. And also we welcome students actually from across all of CUNY, but we actively promote into Baruch College as well. Anybody on the call today from Baruch? Give a little digital hand raise if you're from Baruch. Anybody? Not sure if, oh, we do have Yuki from Baruch representing. Wait, we've got two folks from Baruch. Mila, right. Awesome. Welcome, guys. Great to have you back. And you two are regulars, which is great. Actually, most of you are regulars. Yosef, I love it. You guys are coming back. Jen Fang, Joshiba, Daniel, you guys have been coming regularly. Benjamin, I don't know if I recognize your name. Are you new, or am I just forgetting you from a past meeting? When I tell us in the chat box, I'm assuming you might be new. Not new. Okay, fair enough. Fair enough. Okay, so let's get started with today's meeting. I'm going to switch over to PowerPoint. And today's meeting title is Analyze That, right? So to follow up on Analyze This, yes, the pun is intended here, right? Analyze That. And if those of you who didn't know what Analyze This was, that was a shout out to a movie, a Billy Crystal, Robert De Niro movie from 1999. And guess what? Analyze That was the sequel to Analyze This. I think it came out in 2003, right? Also a pretty good movie with the same stars. But in fact, we're calling it Analyze That because it's really, again, coming back to the topic of building your analytical skills, except this time, rather than concentrating on finance, we'll be concentrating on operational metrics. Now, show of hands, digital hands in the chat box. Raise your hand digitally if you were able to get to any of this week's challenges, any at all, any of the 7, 5 plus 2 extra credit. Digital hand raise for me. So far, seeing nothing. Hang on. Okay. Possibly none of you got to it. I know finals are coming up, so perhaps you weren't able to get to the exercises. We will go over them today. You know, that's okay, because we can talk about it live and in person. So are you guys ready? We already went over how you're doing. You ready for some mathletics? I love it. I love Tuesday evenings. I'm glad to have you guys here today. So yes, people, math is not only meant for finance and accounting, okay? That's really the mantra of today. What we're going to demonstrate to you is how math comes up in other areas of business, right? Beyond finance and accounting. We obviously can recognize how numbers are important in accounting. That's kind of obvious, right? And I think we also know why numbers and math would be important in finance. But did you know that math plays a critical role in operations as well? Now, on that note, let's step back for a second. Raise your hand if you've taken, I know most of you are from Brooklyn College. Raise your hand if you've taken Operations Management 3430 or in it now. Raise your hand if you've taken 3430, BUSN 3430, or if you're in it now. Whoops, sorry. We've got 1, 2, 3, 4 hands up, 4 hands up, 5 hands, 4 or 5. Excellent. All right, so I'm going to call on Yuki. Can you tell us, just in your own words, Yuki, how does math, no, Yuki, what is operations? What is it? We talk about operations, Yuki. What are we talking about?
So I taught operation course last semester at Baruch College, and I think it's to help a company or entity to operate fluently and smoothly.
Okay, yes, I like that. But can you put it, all right, that's good. Does anybody want to put it in their own words? Anybody else want to put what operations is in their own words? And I'm really interested in talking about how operations compares or juxtaposes itself from other disciplines of business. Anybody want to take a shot at that? And it could be someone who didn't take operations management yet. That's fine. How does operations juxtapose itself up against other disciplines of business? Anybody want to try? No? All right. Well, let me kind of help you out on this one. Okay. So when I teach operations management, right, we step back and the first thing, hang on, there's something in the chat box. All right, we've got Benjamin saying it's all about inventory, Jashiba, strategy and process, Benjamin and service. Okay, I like it. It's not all about inventory, but inventory is a big part of operations, absolutely. Strategy, okay, you can say that that's also related to operations. Process for sure, right? But here's how I like to think about it. I like to keep things super simple, by the way. I think if you haven't figured that out already, right? I think simple is the way we learn best. So if you think about business, I like to just generally break it down at super high level, right? There's sales and marketing, there's operations, and there's finance and accounting. Just think about those three big buckets. Put them in three buckets. Sales and marketing in one bucket, operations in another bucket, finance and accounting in the third bucket. And what I like to say, like if I was teaching this to like a 10-year-old and trying to talk about like what that means, here's how I would describe it. Sales and marketing is about selling stuff. Operations is about making stuff. And finance and accounting is kind of like counting stuff, or in this case, counting the money. It also kind of relates to buying stuff. Maybe you can say it's related to buying stuff or paying for stuff, counting the money, right? But sales and marketing, selling stuff, operations, making stuff. Operations is the driving force in any business, whether it's producing products or services, in how that business turns raw materials into an added value product or service that sales and marketing goes ahead and sells, right? So operations role is making that whole engine run smoothly. So, yes, it's about inventory or inventory management or inventory control, but that's just kind of one area. And yes, service, but be careful, Benjamin, right? Service, yes, but some people might put customer service in the sales and marketing bucket, right? It's a different element of service here that we're talking about. You might think, yeah, you can definitely argue service comes in, but it will be more about making sure that service is happening efficiently. Like we can put the word efficiently in there, and then we're talking operations. Okay. So you can imagine if we're talking about making stuff, right? Or basically figuring out how to get that value add in your business. This is a critical part of the business process and often gets underrepresented in people's minds. There are actually probably umpteen more operations oriented jobs out there than jobs in sales and marketing and finance. It's just that sometimes in New York, because New York is such a sales and marketing as well as finance oriented city, many times the whole operations side gets kind of lost in the shuffle because it's not like as marquee in New York City as those first two are. So within this world of operations, guess what? Math matters too, right? And we're going to talk about in these challenges today how different ways how math comes into play with respect to operations. Now, again, just to make the final comment here, well, not the final comment, I also want to, before we get started, make sure that you guys especially for the newbies on the call, right? We've got a 30-minute math challenge. We like when people get on and get involved with MathMinds for the first time and take our 30-minute math challenge. Michelle will post a link to it in the chat box. We already talked about the YouTube videos, right? There's a YouTube channel, subscribe to it. Michelle will post a link there as well. And then, guys and gals, please share the MathMinds promo, okay? This is gonna be even more important. We've only got a few weeks left, okay? But I was sitting here I can't tell you right now how important it is to get more people on next week's call. Why? Because next week we will be talking about something that's really, really, really important within the world of business, where I assume most of you are looking to go upon graduation, right? And we are going to be blessed with two guests who work for the company Salesforce. Now, raise your hand if you've heard of Salesforce. A little digital raise if you've heard of Salesforce. Digital hand raise. Who's heard of Salesforce? One, two, Jen Feng, Mila, Benjamin, a few of you. Okay, Daniel, great. Salesforce is one of those tools that sometimes might get overlooked in an undergraduate program, or especially if you're not a marketing major, you may not run into this. Okay, but if any of you want to go in the direction of sales or marketing or any client-facing job, Salesforce is something it behooves you to know what it is so you can talk about it intelligently on an interview, right? When you're looking for that job after graduation, right? If you can demonstrate that you at least know something about Salesforce, it's going to definitely give you a leg up in a job interview. This is a critical piece of software or a critical application that most companies are using, okay? And we'll get into more next week what Salesforce is, so I'm not going to talk about it now. I will say it is a CRM tool, and I'm not going to even tell you what CRM is. I'm going to ask you to put CRM Salesforce into Google search and check yourself what CRM means, and then you'll understand why it's important. Okay, but next week, super important. So share our flyer, share our information with your fellow students, get them on the meeting next week, and of course, make sure you're here as well. Okay, digression over. Back to the math mission. Analyze that. Oh, so Analyze That was a 2002 sequel to Analyze This. And of course, this math mission is kind of like a sequel to last week's math mission. Okay. Basically, what did we do? We created missions or challenges that are operationally motivated, right? Missions and challenges that you would typically see in various operations management type roles, and show you how math and data visualization comes into play in operations jobs. Okay, so let's dive right in. Okay, and by the way, some of these exercises use Excel, or we encourage you to use Excel to solve them, and some of them do not require the use of Excel. So we're continuing with the theme of getting more familiar with Excel. The first exercise, challenge one, and by the way, there are a lot of challenges today, right? So we broke it up. There's 5 challenges plus 2 extra challenges. And based on time today, we'll probably breeze through quickly the last 2 extra credit challenges. But I will tell you, remember people, we are tallying who responds correctly to what challenge, and Michelle in the background is tallying that up. And when we're done on May 4th, we are going to look and we are going to add up who and give an award or a prize to the person who answered the most challenges correctly. So definitely don't forget about that. Okay, so let's go challenge number 1. Your business owns 3 machines which can each produce widgets but work at different rates. Machine A can produce 15 widgets in 30 minutes. Machine B works twice as fast as Machine A, while Machine C works at 1/3 the rate of Machine A. If all 3 machines work simultaneously, how long will it take for 150 widgets to be produced? Now, think about that. Let me give you guys a minute just to think about it. Maybe someone wants to give it a quickly try to solve. So I'll pause I'll stop talking for a minute and let you think that through. All right, so we're back. Let's talk about how to meet this challenge. Yuki, would you like to unmute yourself and explain your answer? If you'd like, I can kind of write what you say.
Oh, yes, but can I share my screen?
Yes, go right ahead. Please let me stop sharing. Yes. Go ahead and share your screen.
So can you see my screen?
Yes.
So the question is about A can produce 15 units in 30 minutes, B is twice as A, and C is 1/3 of A. So this is based on what they can produce in 30 minutes, and the second column I put how many units they can produce in 1 hour. So A is 30, B is twice as A, which is 60, C is 1/3 of A, so it's 10. So the total is 100 units they can produce in 1 hour, and they need to produce 150 units in total, so just divide them and get 1.5 hours.
Love it. Excellent. Now, Yuki, I'm going to throw you a curveball, okay?
Okay.
So what would happen if the information was given to you in a different way? And for example, machine A, 15 widgets per 30 minutes, but machine B, let's say it said, instead of twice A, let's say machine B made 40 widgets in 60 minutes. 40 widgets in 60 minutes. Okay? And leave C the way it is. C is the same. So B, I'm changing it to 40 widgets in 60 minutes. How would you use that information and solve?
So you said 40 in 1 hour, so I will put 40 here, and it will change to they can produce 80 units in 1 hour. And
But be careful, Yuki, because I never said that A and C machine are still per 30 minutes. You follow me? So machine A still produces 15 in 30 minutes. Machine C still produces 1/3 of A, but machine B now is given the information 40 units in 60 minutes.
Then A and C are not changing.
Correct?
So they still the same.
Correct. How about B?
B changed to 40.
But is it 40? Because it's 40 in 60 minutes, whereas the other ones are based on 30 minutes.
Oh no, the first column is based on 30 minutes and the second column is based on 1 hour.
Oh, I see, because it's already based on an hourly basis.
Yeah.
Fair enough. Okay, fair enough. You got me there, actually. So people, what I was trying to illustrate was that, and that was a great job, Yuki, and I love the Excel application. The key on a work problem, this is a work problem. This is actually an homage to a GMAT exercise. If any of you ever want to take the GMAT exam for going to grad school in business, this would be the type of question that you might see. The key on adding rates together for different things is that the time element must be consistent. So in this case, Yuki made them all on an hourly basis. You don't have to do that. You can make it on a 30-minute basis. You can make it on an hourly basis. Doesn't matter. What does matter is all the three machines in this case, they must give you the information in terms of the output must be based on the same time fixed time metric, 30 minutes, 60 minutes, whatever you want. Okay. So that was really nice, Yuki. Yuki, can you unshare your screen so I could go back to my slides? Thank you. Now, did anybody have a different way of thinking about it or kind of want to share their thoughts here? Feel free to unmute. No? That was pretty clear.
Yeah, I kind of had a different way of going about it.
Okay, can you just say your name so I know who talk?
It's Lee Fenson.
Oh, hey, welcome back. Okay, go ahead. Tell us how you went about it.
Hold on for a second.
And Lee Fenson, do you want me to share? Do you want me to write on your behalf, or do you want to share your screen, or you want to just talk about it?
You can write. Okay, so the way I did it was, let me see. Let me go to my slide. I just divided it up. I just divided it up to 3 columns on my Excel worksheet. I had 1 column for machine A, B, and C. Let me see. I think it'll be easy if I just showed my screen.
Yeah. Let me unshare, and you can go ahead, share your screen.
Okay, give me a second. Okay. Share. So the way I did it, can everybody see my screen?
I can, so I assume everybody can.
Yeah, so the way I did it was pretty simple. As I go back to the question here, what was the question again? Totally forgot, sorry.
Well, I could just tell you, it's how long to produce 150 widgets is the question.
Right, and you know, based on what I've got here, I just put a section that says how many and the time allocated. And to produce 150, I just basically separated by itself. You know, the time it'll take for machine A to produce 150 would be 300 minutes. For machine B would be 75, and machine C would be 100. And I know that my interpretation might be a little confusing, so I'm gonna go explain my interpretation of it.
Okay.
You know, so as we see here, it says machine A can produce 15 widgets in 30 minutes. And this is what I have right here.
Right.
Machine B, I interpret as machine B works twice as fast as machine A. Right. And when I think of twice as fast, meaning that it works in half that time. So that's why I have 15 minutes and 30 widgets in 15 minutes.
But hang on, can I stop you there? Because you're gonna run into an error here. So let's deal with that, because this is a fundamental mistake that some people would make. Okay, what you did, remember, and when we think about rate, right? Rate is some productivity, whatever it is. It could be like the speed of a car is miles per hour, right? It's some productivity. In this case, it's manufacturing widgets divided by time. Okay. So for example, if I said my car is driving on the highway at 40 miles an hour, right? And your car is going twice as fast. How fast are you going? How fast are you going? I'm driving 40 miles an hour. You're going twice as fast. How fast are you going?
I'm going 80
miles per hour, right?
Yes.
The hour doesn't change. What changed, right? The hour doesn't change. So it's okay to have 30 widgets is twice as productive, but it's happening over the same time frame. You follow that?
Okay, yes, I see now.
Now, I do want to point something out, though. I do want to point something out, because you could have done this another way. So since we're on the topic, another way to think about twice as fast, you could have done 15 widgets, the same number of widgets, but in 15 minutes. You follow me? Right? That's another way to think about it. You could have thought about this as 15 widgets in 15 minutes, but the better way to do it, since we're going to be adding ultimately the productivity of the machines working simultaneously, is to put them on the same time frame. In this case, keep it at 30 minutes, or like Yuki did, make it all based on 1 hour. It's another way to do it. Okay. But continue. Now you know it should have said 30 widgets in 30 minutes. And now what does that mean for machine C, by the way?
Machine C. Machine C is based off machine A. It says 1/3 the
Right.
rate.
Right. So what? Right.
I'm thinking, okay, I'm not gonna think about time no more. I'm
Good.
thinking about
Okay.
the productivity, and that
Good.
would be 10.
Is that 1/3 of 15? Is 10 1/3 of 15?
No, it's actually 5.
Correct. 5. There you go.
Okay.
There you go. There you go. Okay. Good. Now, what do we do now? What do we do with this information now?
I have to find out for machine C, I have to find out how long would it take to make 150 widgets.
Working together though, right? Oh, you want to do it for machine C. Fine. Okay. So how long for machine C to make 150 widgets? How long would it take?
It would be, I think, 30. Wait.
It's making 5 in 30 minutes. You want to make 150. Tell me how you're getting that though. Tell me how you're getting it. Take your time. Take your time.
Okay, my primary thinking is multiply 30 times 5, which will get 150. And then I just multiplied 30 times 30, which will give me 600.
No, but I don't want you to think about it that way. I'm gonna give you another way to think about it, okay? I'm gonna give you another way to think about it. And I'm not sharing my screen. So you know what? I'm gonna ask you, since you're sharing, okay, just click in a cell, click in any cell, just click in a cell, click anywhere. Okay, fine. Put in there, so we know, and everybody pay attention to this because this is like important that you kind of get a sense of how to work through rate exercises with multiple things, producing stuff, okay? It's an important thing. So we know that machine C does 5 widgets in 30 minutes. So put in a cell 5. Just put 5 in a cell for me, like there, fine. Now in the cell below it, put 30. Put 30. Okay? Okay. Now next to it, think of it, I want everyone to think of this as a proportion. That's the way we do this. So we know that we can produce 5 widgets in 30 minutes, but we want to know how long for 150 widgets. So line it up properly. Put 150 onto the right of the 5. Type in 150 to the right of the 5.
So around right here?
Yep. 150. Now, and then where the cell is now, just put X. Type in X. X's are unknown. Okay? And okay, so now can you justify that right? Justify it right. Just change it. Just go to the cell, go up to, justify it right. Yep, there you go. Okay, now people, make believe that you had 5 is to 30 on the left side equals 150 is to X. Now, so think of that, that's called a proportion. Now, right now, we're doing this in Excel, so, I can't write a little equal sign, but you can think about 5 is to 30 as or equals 150 is to X. Now, look at this now. 5, that X is going to be a big number, right? Because 5 takes 30 minutes, so 150 is going to take a lot more than 30 minutes, right? So we know we're looking for a pretty big number. So mathematically, we could do what's called cross multiply. Or you can say, how many times does 5 go into 150? Do you know, Lee Fenson? How many times does 5 go into 150? Any idea? Like off the top of your head, or if you need to, use a calculator and do 150 divided by 5.
30.
Or you know what? You can use Excel to do it. 150 divided by 5. You can do equals 150 divided by 5. This is going to tell us how many 5s go into 150. So it's 30, right? So if it takes 30 5s to go into 150, you got to multiply the 30 at the bottom also by 30, which makes 900. I'm just telling you it equals 900, but you can do equals 30 times 30 to do the math yourself. But basically, so we know that unknown is 900. Okay, 5 goes into 150 30 times, 30 goes into 930 times. Okay, so now your cell H7 is actually 900 minutes. So it takes 900 minutes for machine C to produce 150 units. But here's the thing though, what do you do now? Now you know how long it takes. And by the way, I'm not sure. No, it's sure. So now you know how much each of the machines independently would take to produce 150 widgets. But they're working together, right? So what do we do now? What do you think? What were you thinking?
I would kind of have to combine all of it up. Not these numbers, because these numbers are separate, but I'll have to combine all of the numbers up.
You will. But you see how those numbers, 300, 150, and 900, they're not additive. You can't add those. It tells you nothing additive because they're working together, right? They're working together at the same time, simultaneously. So clearly, we're not adding those numbers. So there's got to be another way to approach this. Any thought?
Not so sure. I'm sorry.
That's okay. No, I'm glad that you participated. So let's go back to kind of how keep it how you have it here now. So let me kind of enlighten you with this thought, okay? I want you to visualize these three machines, A, B, C. Visualize them in your head and visualize them working together, like at the same time. You turn them on, they're all working at the same time, right? So Lee Fenson, 30 minutes go by. 30 minutes go by. All three machines are working. 30 minutes go by. How many widgets did they produce? 30 minutes go by. How many widgets did they produce?
50.
Yes. How'd you get that?
Because since all of the time, I just added the widgets together within 30 minutes, and I got
Now
50.
what exactly? Now that's additive. Now the number in row 7 is not additive, but that's additive. Why? Because, and listen to this, everybody, because you can add rates of independent machines or whatever it is when the time periodicity is the same, right? It could have been per hour, per minute, per day, per month, per year. It doesn't matter, okay? In this case, it's per 30 minutes. If you know that these three machines can produce different amounts over 30 minutes, if you think about them all working together, they are producing 50 widgets in 30 minutes. Now we're getting close to the answer because you've determined that together they're producing 50 widgets in 30 minutes. Now, Lee Fenson, in cell I4, put in 50, I4, put in 50, right? And below it, you can type in 30 minutes again. It's like the same, right? So basically, and now put in cell I3. In I3, just put in A space, B space, B space, or something like that. That's to indicate ABC. Just put ABC. That's to indicate all three working together. Now, if all three working together produce 50 in 30 minutes, how long will it take them to produce 150? Yeah, put 150. I like that. Now think about what we did with the proportions below. How many times does 50 go into 150? How many times? Or did you say 3?
Yes.
Correct. So multiply our time value by 3. What do we end up with? 90 minutes, exactly. Done. You got there, okay? Now you see, everybody, we spent a lot of time on this, but this is like an important exercise to illustrate how we can use, how when we're working with different rates of different, whatever it is, could be people, could be machines, whatever, and how we can add that together, when we can add, how we add, and when we can't add. And that was well done. We got to the same answer as Yuki now. Okay. Yuki did a little bit different, but in the end, all Yuki did was express her rates per hour. We didn't do that. It doesn't matter. We expressed our rates per 30 minutes. That's the only difference. But in the end, the moral of the story is when you add machines or people working simultaneously, the time periodicity for all three must be the same. Okay. Thank you for that. Can you unshare your screen so I could run back to my presentation? Just go ahead and unshare Lee Fenson. Or
I'm not
stop
sure how you
share.
do that. Oh, I see.
Stop share on the top. There we go. There we go. There we go.
Some more people shared in the chat too.
Okay, let's check out the chat box. Hang on. Go back to my presentation. Chat box. Come on, chat box. Where are you? Okay, in the chat box. Joseph, I calculated per minute. That works. You could calculate per minute. I like that. Like I said, it's just a matter of making the time periodicity the same. So Muhyiddin used 30 minutes, fine. And Jin Fang did exactly what we just did, Lee Fenson, in the chat box. Same thing. Okay. Woo! My God, that was only challenge 1. And that's okay. It's worth it. It's worth it. So let me share with you real quick the slide. So what I have on the slide here. So here's three machines. Here they are per 30 minutes. Together they can produce 50 and 30 minutes. We just talked about it, right? Here's the proportion I talked about. Proportion is your friend in rate exercises. Proportions are a great way to kind of model your answers when you're kind of still a little bit rusty on rate problems. Okay, so here's the work. You would solve for X, and in the end, when you solve for X, you get 1.5 hours. Woo, okay, I like it. Let's move on to challenge 2. Challenge 2. Challenge 2 had some data in the Excel file, tab named challenge 2. There was sales data, of course, made up sales data for 90 days, okay? Doesn't matter what it was for. And what we want to do here, one of the things we do in operations, by the way, is we do forecasting. And by the way, this is kind of a cross between sales and marketing as well, because it's really a sales and marketing task in the end in terms of forecasting. But I'm digressing. So sometimes we talk about creating a moving average. And we do moving averages because it kind of takes the noise out of our forecast. Like when numbers are bouncing around quite a lot, a moving average kind of calms down the bouncing. Let's kind of just put it in terminology like that. Okay, so the question here was to create a 7-day moving average starting on day 8, noting that day 8 is basically the average. The day 8 moving average would be the average of days 1 through 7, and so on and so forth. So your first task was to create that moving average, and the second task was to put it on a graph, okay? Put it on a graph, both the data and the 7-day moving average, and then to put a cherry on top, add a trend line. Use Excel to add a trend line, which is beautiful because Excel has a way of doing that without doing the math. Okay, so did anybody get to do challenge 2? Anybody get to do it and want to share how they went about it? Let's check the chat box. Yes, Yosef, we are going to use the average function. Yuki, you answered one already. So before you go back, let's see if anybody else wants to jump in first. Okay. Anybody want to show us their solution? Anybody? Going once before Yuki comes in again. Yuki's getting lots of points here. Going twice. All right, Yuki, you're up. You want me to stop sharing, and you want to share your screen, or how do you want to work it?
Oh, I want to share my screen.
All right, I'm going to stop the share, and take it away.
So this is what I did. As the question described it, we need to calculate a 7-day moving average. So it means on day 8, we need to calculate the average from day 1 to day 7. And the same on day 9, we need to calculate the average from 2nd day towards the 8th day. So we need the average function to calculate 1 to 7, which is here. And when we type this function, then we double click it and we copy the formula to all those cells below it. And each of it will calculate the previous 7 days before it.
So Yuki, Yuki, randomly click on some lower day moving average. Double click and double click. Now, people, do you see where it's grabbing the cells? Like this one is grabbing 11 through 17. So anywhere Yuki clicks, because she dragged the formula down, it's taking the previous 7 days and averaging it. It's a great thing about Excel. You can drag formulas down. Okay, sorry, Yuki, go ahead.
And then we need to make a graph about the daily sales and the moving average. So we just need to create this whole table from A1 towards C100 or C91.
Why don't you just make another, can you make a new graph just so everybody can see how you do it? Just
Yeah,
make
sure. So click insert and then the recommended chart. And I will choose this one because the column represents the daily sales and the line is representing the moving average.
Okay. Wow, that's pretty easy, right, people? It even recommends for you. I love it. All right, keep going.
Then we need to make a trend line. You can either make it for daily sale. I will make it, change it. So you can see clearly. So this line is for the trend of daily sales. You can also adjust it to the moving average trend. This is the red line now. And that's it.
I love it. All right, can you change the chart style? Go back to where it recommended the chart and pick on the, give me the one, not with the line bar, but the double line graph. So that was like when you first started it, and it's none of these. You have to go back and maybe start over again or change chart type.
This one?
Yeah, exactly. Can you show us that one?
Yeah, sure.
All right. So Yuki, can you interpret the blue line versus the red line for us?
The blue line is for daily sales and the red line is for the moving average. So you guys can see the blue line changed rapidly and the moving average didn't change so much and near the trend line. This is because when we use the moving average, we remove some noise and some like unexpected issues about the daily sales. So it will remain relatively stable than the sales data.
Right. Now, tell us what the trend line is. The trend line telling us anything?
Yes, the trend line tells us that we predict that the sales is increasing.
Right. Beautiful. You all see that? The trend line, the trend line is going in the direction we want it to for sales, right? It's going up. That's a good sign. Now, by the way, people, this data is literally, I used a random function. I randomized the numbers. It just worked out that it happened to be trending up, okay? But I literally randomized the data And that's why the blue line is so all over the place, because it's literally randomized. But this is great illustration of how a moving average looks versus actual data. And then it's there to show you how easy you can add a trend line. Now, adding a trend line on my version of Excel is a little bit different from Yuki's version of Excel. It's important that you all realize that, like Excel on your Mac or Excel 360, like if you're using Windows 360 on the CUNY system, or Excel on a Windows laptop or tablet, it's gonna look slightly different. Also, if you have an older version of Excel, like I use like Excel 2011, okay, it's very old. So my functions are a little bit different if you're using like a newer version of Excel. So don't get intimidated by that though. You don't want it when it comes to using software like Excel or Word or PowerPoint, you don't want to get too stuck on where things are, because it's always going to change, right? When the software comes out with new version, you have to get comfortable with the new version. So you want to develop a certain level of nimbleness, not to worry about like, okay, I don't know why is now a trend line in a different place, okay? You have to kind of get comfortable with the fact that you may not know where something is, but you can always find it. You can always find it, okay? And when you have that level of comfort, it removes the anxiety of not knowing where something is, okay? But that was great, Yuki. Yuki gets another point. Good job, Yuki. You're doing great. If you want to unshare your screen for me so I can then share mine back, thank you. That was great. Let's go back to the presentation. So I have a very similar slides here. Here, see this? Look, it looks exactly the same as Yuki's, right? Looks exactly the same. So here was my graph that I created. And by the way, it's also important, people, to understand that, one thing that's important about data visualization is like sometimes when we just formulate the graph, it may not look nice. And sometimes we have to change the axes. In this case, it worked out great the first time, but sometimes we want to fix the axes to have the data tell the story we want it to, okay? So if this axis was different, like imagine if the chart looked like this, right? Instead of what you see there, right? And here's my chart. That wouldn't be very meaningful. So if that was the case, we'd probably want to change our y-axis, right? So that we're only showing, let's say, from here, the range from here to here, demonstrating the bigger bounces, just as an example, okay? So you have to also get comfortable on formatting your graphs. Excellent. Challenge number 3. We're moving along. This one actually doesn't have much math at all. But when you take an operations management class, or if you took it already, you might recognize that one of the things that your professor may go through are kind of like different types of operational graphics that are used for different things, right? You might, be talking about in project management, you might be talking about an organizational chart, something called a fishbone chart. Maybe you've run into a Pareto chart. And one of the other common charts is a flow chart, the flow chart. So this exercise was meant for you to visually diagram the flow chart that represents this process, right? So the process here is, it's all made up, by the way, right? I made this up from my head, okay? Imagine you're going to a medical office, or you're representing a medical office, and you want to flow chart out the whole process of going of a patient making an appointment, going through the process of actually, showing up at the office, having the visit, and then leaving the office, right? So this exercise had 10 steps that you needed to visually show in a flow chart. And there are different ways to do this, right? Some people might use different colors, other people may not. You can use different shapes, other people may not. It doesn't really matter. It's really more about getting the flow chart logically looking correct. Now, did anybody, maybe we can go besides Yuki for now, for right now, did anybody work out a flow chart for this challenge number 3 that they would like to share with us? Anybody want to jump in? Going once, going twice. Okay, so I'm going to pass it to Ling King. Ling King, I know that you worked on this already, our math mentor extraordinaire. Ling King, would you like to share your flow chart?
Yes. Give me
All
a
right,
sec.
I'm going to stop my share and give you an opportunity to share your screen if you have it available. If not, I can share mine. You tell me. All right. So here's Ling King's flow chart. Now talk us through the flow chart, okay, Ling King? Are you able to make it a little bigger? Okay.
Hey, give me a sec. Yeah. So basically, when we start flowchart, usually they use oral to start. So we start appointment first, and then call for confirmation, right? If it's no, just go back to the first step. So, and then if it's yes, we move forward to the next step.
So hang on, because some people may have not, that are on the call, probably don't have the steps memorized because they may have not done this. So why don't we actually just talk out the steps? So the first step is schedule an office visit appointment, right? So someone schedules the appointment, like, you know, it could be a month in advance, whatever. And then that's the oval. And then the diamond below is the office calling the patient, for example, 48 hours in advance, maybe, to confirm whether or not the patient's still coming. So take it from there, Ling King.
Yes. So after calling the confirmations, when the patient is arrived, they will go to the waiting room. So if it's a new patient, you need to fill out a new medical paper. If it's not, just go forward to check in. It's the right one going on. And then after they check in, they are examination by the nurse. And then after that, go with the medical doctor in the examination rooms. And after exam the doctor, if there's no other needs, no other more cares, you just go complete the appointment and leave. If it's yes, return to the front desk, ask for specialist or sketch. And then that will be the end of the completion.
Nice. Now, Ling King, I have a question for you. Is there, I noticed that some of them are diamonds, some of them are diamonds, and some of them are rectangles, and a couple of them are ovals. Is there some reason why you chose like the diamonds? Are the diamond ones, do they share something in common that made you make those diamonds?
Yes. So if when we're using if yes or no, we're using the diamond for the choices.
Okay.
If it's a process, we use the rectangle, and then at the beginning and the end, we use the oval.
Nice. So I think so did you catch that, people? Diamonds were for decision points. Rectangles were for process, and her oval was for the beginning and the end of the flow chart. I like it. Anybody have any questions for Ling King on that? On what's going on here? Any questions? All right, no questions for you. Thank you, Lin King. Can you unshare your screen and I'll go back to the presentation. Thank you for that. So this was thrown in here, people, because MathMinds is not only about math, it's about thinking mathematically. And thinking mathematically, a cousin of thinking mathematically is thinking analytically. And when we think analytically, a lot of times that really comes down to telling stories with numbers or with diagrams or with graphs, right? That's a big part of what your job would be working in for any company. So you want to be comfortable with kind of being able to show a process in some type of graphical manner. Now, I have another version of this is similar to Lane King's. I just happen to do it a little bit differently. But I mean, obviously it's the colors are different, but the concept is the same. The only difference here is that I chose to make the rectangles operations done by the medical office, and the blue ovals are actions taken by the patient, right? So there's not one way you have to do a flow chart. The key is does it tell the story you want it to, right? The key is making the flow chart to match what's going, what you expect to happen in terms of the breaking down the process. And why is this important? Because when we look for areas to maybe create some efficiencies or make the service better or identify gaps or areas of concern, having a flow chart allows us to break things down into a level of detail that we might not do if we don't task ourselves to doing this. For example, do you know that when you think about Starbucks as an example, right? So Starbucks is a big company, right? Obviously, they're selling lots of coffee and other things. And Starbucks has, over the years, spent a lot of time analyzing the process of serving their customers. And I've seen flow charts and whatnot like this literally on the process of ordering like an iced drink, and sort of processing through the entire thing from taking the order, grabbing a cup, scooping the ice out, filling the cup, whatever is involved there. And it was actually, this is a true story. That's actually something that Starbucks did do. And from that work, what did they do? At one point, they changed the ice scoopers. They made the ice scoopers match the size of the amount of ice necessary for their three main sizes, right? Tall, grande, and venti, so that the barista would have to always just make one scoop and wouldn't have to go back and make a second scoop, or basically, to get the amount of ice correct, right? So that work, or that operational improvement, came from an analysis using charts such as this. Okay, so I digress to demonstrate to you where this stuff really matters. All right, let's move on to challenge number 4. So challenge number 4 is addressing something called seasonality, and introducing you, or some of you, to the idea of a seasonality index. And this is another important metric and numerical metric that it's important to understand what it is, how to calculate it, and why we do it. Okay, so in this exercise, you're given an annual forecast for some, doesn't matter what it is, for some company that's going to sell next year 12,000 units, but your business is seasonal with peaks in the summer and winter months, right? So the summer and winter is busy, and your fall and spring are less busy. So you'd rather see a seasonally adjusted monthly forecast, not this annual forecast of 12,000 units. You want something that matches what you would expect, what you're going to expect to see month to month. So one of your operations analysts created a list of seasonal indices for each of the months, January through December, for you to consider. They're detailed here in this chart on the slide, as well as in challenge 4, the tab challenge 4 in your Excel file. Okay. And your goal in this challenge was essentially to fill in the yellow cells, basically fill in the monthly forecast with seasonality using the seasonality indices for January through December. And by the way, indices is plural for index. Okay, just in case you weren't aware. All right, who would like to jump in? Because even if you haven't done this already, if you kind of have a sense of what's going on here, you should be able to take this challenge on right now. Who wants to take that on? Who wants to volunteer to walk through how to calculate the forecast using the seasonality indices? Any volunteers? Come on, people, score your points. We have something in the chat box. Yosef is commenting. I thought it was 1,000 divided by 115 times 12, but I don't understand my results. Okay, well, if you don't understand the results, that usually means there's something wrong with the math. Usually. So Yosef, would you like to volunteer to, kind of think this out with us? What do you want to unmute yourself? Maybe Yosef's not in a place to unmute. Okay, fair enough. Anybody else? Understood, Yosef. So Yosef, I will tell you that you're on the right track, but there's one thing wrong there. Anybody have a sense of how to work this? Anybody else want to give it a try? All right, we'll open it up then to Yuki or to Ling King. And I see Zach just jumped into the meeting. You can also join us.
Hello.
Hi, Zach.
How's it going?
Doing well, Zach. Did you have a chance to try this exercise, or are you familiar with seasonality indices?
Not really. This week has been kind of nuts.
Fair enough. Are you familiar with what a seasonality index is? You've seen that terminology, or do you recall?
I feel like I've heard that before, but I'm not really sure what it is.
Okay. So would you like to be the person who I walk through to get this problem solved?
Sure. Let me just. Do I need to open up Excel or anything, or what should I do? I just like got everything together. So.
Just get a calculator. You have a calculator?
Yeah, I have a calculator.
All right, let's talk it through. So have you read the challenge here? Why don't you quickly look at the challenge? Read it real quick.
Business seasonal. Okay.
All right. So we know we've got 12,000 units for the year. That's our forecast. And we want to get a better monthly forecast, right? Rather than just saying 12,000 for next year. Now, if we had no information, right, and we were to sort of just average out the monthly sales without seasonality, do you agree that you end up with 1,000 per month?
Yeah.
Great. So the first thing we would do is, so it's already done for you. Here's our forecast without seasonality. Now, do you see that in the exercise, it said that sales in the summer and winter are higher, right? There's peaks in the summer and winter.
Yeah.
So what would that mean to you? Like that means that like January and February, we expect to be greater than 1,000, right? And in the in the spring, less than 1,000. In the summer, back greater than 1,000, and in the fall, back less than 1,000, right? Because that's sort of the following the peak winter, spring, summer, fall, right?
Yeah.
So we expect our results to look like that. Now here come these seasonality indices. Now look at the numbers, Zach.
hmm
What is it? Just take a look. What is it? What are you thinking? What are these numbers kind of, do you see how they're changing?
Yeah, they're changing in like a sort of like curve, like waves. Like
Right.
they like it goes up and then it then peaks and then it goes down and peaks down and then so on and so forth.
And by the way, let me just point out to everyone on the call right now, as I created these exercises literally from scratch, as I'm looking through it now, my seasonality indices do not match what the exercise says. So let me just make that point right now, but it doesn't match. So I actually made an error. So if I was the operational analyst, I should be fired, okay? Because my seasonality indices do not match a summer and winter peak, okay? And I'll explain why in a second. So let's start with January.
Mhm.
How do you think we might use this index of 115 to adjust this 1,000?
So my knee-jerk thought process is that the index number equates to like some sort of percentage maybe, and
Yes.
like 100, like 100 would be 100%, which would be $1,000 because that's the average.
Yes.
So like for January, if the seasonality index is 115, it would be 115% of $1,000.
Yes, exactly. Indices like this typically revolve around the number 100. And when they do, when they're offered that way, as you just said, 115 is like 15% greater than the average non-seasonal number, right? Or 115% of the 1,000, right? So
Mhm.
exactly. So what's the math? What's the math to get January seasonally?
So I mean, I'm sure there's like an easier way to do it, but what I would do is find 15% of 1,000 and then just add that to a
Okay,
thousand. So and
that's
that way and
fine.
that got me 1,150.
And you'd be correct. You'd be correct. It is exactly 1,150.
Yeah.
And we
The
would
other
take,
thing,
go ahead.
oh yeah, the other thing that you could do also, since I mean 1,000's like a pretty, I feel like a simple number to work with because it's like very much even and like standard.
Right.
You know, you could essentially just like you know you would know that since it's 115%, it would basically be like 115 with a zero afterwards. You know what I mean? Like so like for 120 it would
You're
be 20.
right. You're right. In this case, you can just add a zero. You can just put a zero on the seasonality index, only in this case. You're
Yeah.
right, though. You're right, though. But let's go back to your calculation. You did the non-seasonal number times the 15 or the element after the one, right? And then
Yeah.
added back itself. By the way, I just want to point out to you, it's the same thing as taking the original non-seasonal number and multiplying that by 1.15. We get the same result. We get the same result. And if you bring that through, people, Zach and others, right, and essentially do that all the way down. Now, how do you think we're going to deal with 95, though, Zach?
Well, you could do 1,000 times 0.95,
Yes.
would give you
So
950.
yes, your instinct is right. 0.95, you know it's going to be smaller, right? And it should be smaller
Yeah.
because the index is below 100. Multiply it by 0.95, we get the answer exactly. Excellent. So in the end, here's what we end up with, right? In the end, using the indices, our seasonality forecast looks something like this. Basically, as you can see, it's it's got a different flow. It doesn't match what I said here. It's got in the first part of the year it's high, in the summer it actually is low, and then in the autumn it's high again, which does not match. I'll say it again, does not match what I wrote here, okay? but that really wasn't the point of the exercise. The point of the exercise was to get you to work mathematically with the seasonality indices. And Zach explained how he was able to do that, and he was correct, right? We think of it with indices like this in seasonality, we think about 100 being like 100% or a level answer. Anything over 100 is overemphasizing. It's something. It's like a bonus, like something better is happening there. And anything lower than 100, it's like a, it's like a discount or something worse is happening there. So an index of 75 is going to be your low point in this case, and an index of 120 is your high point. Nice job, Zach.
Thank you. Thank you.
All right. I like it. Challenge 5. Challenge 5. Challenge 5 is just to introduce another concept of applying some basic probability to different alternatives and just throwing in the term expected value. In this case, expected monetary value, but really we're talking about more generally expected value. So in this exercise, you have three. You're looking to make an investment decision. You have three alternatives. You can invest in brick and mortar, online, or don't make any investment at all and do nothing, right? But we don't know how the economy is going to go. And you've got some information that suggests that if the economy goes well, here's your payoff for the three alternatives. And if the economy doesn't go well, here is your payoff. And by the way, a red number with parentheses in accounting means a negative number. So even though you don't see a negative sign here, these are meant to be negative 370 and negative 50 or 50,000 and 370,000.
Does that mean we're losing money or?
Correct.
Or...
That would mean you're losing money. Correct. So in a case of a favorable market, you'd make 500,000 for brick and mortar. In a case of an unfavorable market, it suggests you'd lose 370,000. Exactly. Now, you also...
How much, sorry to cut you off, how much would we be investing if the payoff of a favorable market is 500,000?
Oh, okay. So this exercise doesn't even have, that's not part of the exercise. So it's a good question, but we'll just take that out of the equation. Right? We're not, this exercise is not meant to do return on investment in the way we talked about it in our finance lectures. It's meant to specifically get at trying to blend two different states of nature. So forget about how much we're investing. Just put that out of your mind. Okay. So in this case, our favorable market is intended on having supposedly is estimated to be 60% likely, and an unfavorable market is 40% likely, right? So by the way, just to go back, Lee Fenson's making an interesting point. If your investment was the same in any case, right, it wouldn't matter. Because in this case, what we're doing is we're trying to look at the alternative payoffs of essentially these three options. So don't think time value of money here. We're not doing that. What I'm trying to illustrate is how we would use information with different states of nature, in this case, a favorable market versus an unfavorable market, and how with that, we would calculate an expected value, okay? So that's the question. How do we calculate expected value of essentially these three possible alternatives? How do we use these probabilities down here to calculate expected value of brick and mortar, online versus do nothing? Who wants to give it a shot, or who has a sense of how to do that? Yuki is jumping in. So Yuki understands. Anybody else? Yuki showing you the actual Excel formula, but let's think about it without not, just think about it more mathematically for a second. What I'm going to get at here is how we use probability to calculate expected value. That's the main purpose here of this challenge. Anybody have a sense? All right. If not, Yuki, you want to explain the math, Yuki, rather than just showing the cell demarcations. Let's start
Yes.
with Yuki. Let's start with the brick and mortar. How do we calculate this number?
So we have a probability of 60% that we can make profit from the favorable market. So we will time the 500,000 and 60%.
So Yuki's taking the payoff for brick and mortar, multiplying it by its probability of occurrence. Okay, that's this number and this number. Okay.
And we did the same thing for the unfavorable market, which is the negative 370,000 times the 40% probability.
Beautiful. So that's this number and this number. So note, Yuki took the payoff for brick and mortar in a favorable market, multiplied it by its expected probability, and added to the product of the payoff in an unfavorable market times its expected probability. And when you do that math, you get how much?
152,000.
152,000. Great. And if we do that for, so this number here is 152,000. And if we do that for online, what do we get?
127,000.
127,000. And how about do nothing?
And 0.
0. All right, beautiful. So here are the expected values or expected monetary value of the three alternatives: 152,000, 127,000, or nothing. Okay. And I think on the next slide, I have it actually building here. I'm not going to go through all these. You can read this later, but basically this is the same math that Yuki just took us through. Okay. So we do that and Yuki's answers are spot on. Get the same numbers here in the presentation. Excellent. Now, Yuki, which is the best alternative and why?
I will pick the first one because we can make most of the money out of it.
So Yuki says this is the best. Wait, can you explain what number are you looking at when you say the most money out of it?
I'm looking at the column in yellow color.
So Yuki's saying she likes brick and mortar because its expected value is the highest. Good. Does anybody, and that's a very rational answer, but can anybody give me any reason why they might choose it in a different way? Anybody have a sense of why they might choose one of the other options? Someone want to say something there? I heard an unmute.
Yeah. I mean, there's probably other like non-numerical factors, that like come into play.
Okay, like?
For example, like if you're doing stuff online, you don't need to like go anywhere. You could do everything so like there's like an ease of use type thing. There's also like
you're right, but let me just guide you a little bit. You're right, there are many issues and some of them could be qualitative, but I want you to stick to these numbers. Just stick to these numbers. Is there any reason why you might choose which direction you go for a based on a different number, not this number, 152,000, but based on something else.
Yeah. I feel like with the with the online, I'm trying to think about like the best way to describe it, but I feel like you kind of have to do less to reach 127,000 than you would to reach 152,000 because of how like the difference in favorable versus unfavorable market. So if you're somewhere in the middle, like you're more likely to have a positive outcome than a negative one, if that makes sense, I think.
Okay. Not really sure I understand that.
Okay, yeah. So I'm saying, let me see if I could like phrase that better. All right. So with brick and mortar, right? I feel like the difference between 500,000, like 500,000 is like a really high goal you have to hit. Like for it to be considered favorable using these metrics, 500,000 is like a pretty high number.
Remember, it's
And
not a goal, it's an estimate.
yeah, right. But I feel like I don't know. I just feel like there's such like a huge disparity between like getting $500,000 and losing $370,000.
But now you're talking about something a little bit different. You're recognizing this disparity.
Yeah.
Okay. So let me help you out. And some people are putting some comments in the chat box, which are good comments. One comment got into return, investment, right? So I didn't bring investment into this, but for example, it would be accurate to ask the question, what's the capital investment? In reality, we know that for the most part, an online capital investment tends to be less than a brick and mortar investment. So if that was true, that would come into play here. But I'm saying in this exercise, imagine the investments are equal. So put that aside. But you're, Zach, bringing up another important point here. There's a disparity. So in other words, you might, okay, so as Yuki said, one might take the position, I'm going to take the alternative with the highest expected value. But another person might say, I'm going to take whatever alternative has the highest payoff. Like you might just decide to go in that direction. So for example, even if this was lower, like 110,000, you still might choose this because you want to choose the one that gives you the most payoff because you just are willing to gamble that you're going to have a favorable market and you're willing to do it. On the flip side, you also might say, I'm going to choose the alternative with the least downside risk. In other words, I'm going to choose the alternative that where I'm going to lose the least, but I'm not going to do nothing because I want to do something. So I'm going to choose online because if things don't work well, I want to lose the least possible, right? Without choosing do nothing, right? Other people might say, hey, you know what? I'm just going to choose nothing because I don't want to take any risk and I'd rather just not, right? I'd rather maybe you have some other alternative and that might be your answer. So I'm having this discussion with you because the answer in reality in business that you would is not always which has the mathematical highest expected value. That's not always the decision point that we go towards. We might go towards, we might use a different managerial thought process. We might choose downside risk, minimizing downside risk. We might choose the maximum of the maxi markets. And when you take operations management, actually, this is part of my course, we talk about maxi min and mini max, right? Maximizing the maximizing or maxi max, maximizing the big number or minimizing the small number, right? So there's different ways to go about it. It doesn't have to be that you're taking the expected monetary value. So I just wanted to put that out there, but I also want you to know how to calculate expected value. Okay, so now we've gone through it. Thank you, Yuki, for explaining that. And thank you, Zach, for your thoughts. Now, people, we are already at 7:35. we have 2 extra credit challenges, and as I thought, it would be too much to go over in one session on MathMinds. So I will just simply ask the question, did anybody do extra credit challenge 1? Because if you did and got the right answer, we are going to give you credit. And Yuki raised her hand. Love it. Yuki, just unmute and tell us your answer, or actually you might have to show us a graph. So I'm going to stop sharing, and we don't have time to go through it in detail. Just show us your answer, Yuki. So Yuki has the correct scatter plot. Yuki has the correct trend line, and awesome. So Yuki gets credit. Yuki absolutely gets credit. I was looking at her answers. She has the correct slope and the correct Y-intercept. Thank you, Yuki. Please unshare. We don't have time to go through it right now. Please unshare, and I will just share my slides. People, if you didn't get around to this exercise, go back and try it. You can look through the video on YouTube later where you'll see the solution building here. When you take the information presented in Excel and then you plot the scatter plot, you end up with a graph that looks like this, and you can add a trend line just like Yuki showed and just like you see here. Now you see the trend line is moving in a negative direction. The exercise, though, asked you to calculate the slope and Y-intercept of the trend line. That's a little trickier. And if you remember in math, our linear line always can be shown in the form y equals mx plus b, where m is the slope and b is the Y-intercept. In Excel, we can use a function called linest. Linest gives us, for any set of data with a linear data with 2 columns, right? 1 column of known x's and 1 column of known y's, and it will calculate for you the slope and the Y-intercept. In this case, the slope is negative 878. The Y-intercept is 1,529. Think about what that means, but you should recognize a negative slope means there's a negative relationship in the data. In other words, housing prices go down as proximity to the waterfront goes up. Now, of course, this is made up data, but in reality, that's usually what we would find, because housing value in proximity to water tends to be higher. Of course, let me make a side note that with climate change, that's changing slightly, like in Miami, where all of a sudden the houses that are right by the waterfront are slowly losing their value because people know in 20, 30, 40 years, those houses might be underwater. So it doesn't always work this way. But in the data presented here, that's how it works, okay? So the data looks like it has a tight fit. So you might say that water proximity here is a good predictor, but let me ask Yuki, which other statistic would be useful to determine if this data, if the proximity is a good predictor of a home value? Yuki, which statistic would be most useful? Do you know?
So you mean the distance and the value?
No. Like have you taken a statistics class yet, Yuki?
Yes.
Do you remember what statistic we use to determine if a data set has a good fit to the trend line?
Um,
I'll give you a hint. It's a letter in the alphabet. I'll give
the
you a hint.
arrow? I forgot.
Yeah, R. Remember the R value or the R square value? The R value in statistics. So we're not going to get into that now, but for those of you who are taking stats or will take stats, you'll see that we talk about the R value being what we look at for determining whether data has a good fit to the trend line. Okay, but I don't want to speak more about that because we are out of time. I will, though, for extra credit challenge 2. Did anybody get extra credit challenge 2? Anybody do this? All right. So for this exercise, again, running out of time. So I challenge you to read the challenge. And if you're watching the recording, read this, pause the video, give it a try, and then unpause the video and let me share with you what the result looks like here, right? So what we basically brought forward is some elements of something called linear programming, which in business, we do linear programming to one application is to find a way to allocate resources in such a way to maximize revenue. So without going into the details, what was presented in this exercise are some resource allocation between two products, A and B, and you're trying to figure out how many of product A versus product B to manufacture. But you have a certain constraint. You only have so much of the resources. And the two resources here that are presented are design time and fabrication time. Okay, so if we use variables A and B to represent the number of units of product A we can manufacture and B for the number of units of products B we can manufacture, and then create a little table like this to show you or to visually express the requirements of design time and fabrication time for the two products, as well as the resources available over the course of the week in this case, we could then show two inequalities. And I recognize if this is new for you, you're not going to get this in one shot. So watch the video and try to go through this on your own. You end up with two inequalities to represent the constraint, the resource constraint for design time and fabrication time. And we could then graph these two equations that you see on the bottom left of the screen and how those would be graphed. And again, just for the sake of time, I'm not going to do it manually. I'm just going to share with you the results. Of course, I highly recommend you try and remind yourself how to graph these inequalities. But in the end, here's what it looks like. The red line and everything to the left of the red line is the graph of the first inequality, and the blue line and everything to the left of it is the graph of the second inequality. And the product mix feasibility is the overlap of these two spaces. So basically what it says is, based on the constraints provided, we can produce any number of units, a mix of units A and B that's in this green product mix feasible zone. And when you are working through this, if you take operations management and you discuss linear programming in your operations management class, what becomes very useful here is looking at the corners of this feasibility region, right? Looking at the corners, because of course we're trying to maximize revenue. So what we end up doing in linear programming is looking at this product mix, and this product mix, figuring out how much revenue it will generate, and then choosing the corner of the feasibility zone that has the greatest revenue. That is a super fast introduction to linear programming. And it's a complex topic, so I understand that you might be like, what is he talking about? Go back, watch the video, go back on YouTube, and do some of your own research. Linear programming is a hot topic and very important in the world of operations management. Okay, people, the mission is complete for today. The motto of the story: know how to tell your story with data. Okay, very important. And again, next week, we are calling our mission Death of a Salesman to pay homage to the Arthur Miller play, Death of a Salesman, and movie with Dustin Hoffman from the 1980s. And what we are doing is a Salesforce demo. You absolutely need to be here next Tuesday to learn about Salesforce. There will be a mission. It won't be a math mission, but it will be a mission nonetheless. So look out for an email from Michelle with what we want you to do to prepare yourself for next Tuesday's Salesforce demonstration. On that note, I will stop the video now. I will stop the video. Thank you for joining if you're watching the recording.